I am now located in our application room here at HP. Inside this room, we have collected a sample part from each of the customers that we are working closely together with. And I'm going to, in this session, to take you through each of the different segments that we are working closely within. That will be the industrial, the automotive, the healthcare sector, and also the consumer goods. And we're going to start off with the industrial sector back here. So this is one of the first applications I want to showcase within the industrial segment. So this is a custom manifold that is used to transfer water into a tank, and it was used in a specific 52 feet boat under a transatlantic rate. It was produced by AMU Factor in the UK, and what they were able to achieve by using multi-jet fusion was to achieve this complex geometry. And with the help of our strong PI12 reusable material, they were able to produce this very dense part that was able to withstand a 20 bar pressure with a 10-day lead time. And this part specifically has a vapor fused finish, which almost resembles a injection molded part. In comparison, you can look at this part, which is similar to what the part will look like when it comes out to the printer raw. So the application I have in my hand right now is an application that comes from the global leader of automation and gripping solutions, which is called Gematic. They are located in Italy, and what they are able to achieve with multi-jet fusion is the personalization of their grippers, which you can see here, the difference in grippers they produce. They are able to produce this for themselves, but they are also able to meet the customer needs because of the possibility to customize in our printer. And because of the efficiency and productivity of our printer, they are able to produce this with a short lead time. So the part I'm holding in my hand right now is a part that IM 3D Hubs helped to produce together with their client Continental. This is the prototype of the final product, and the final product ended up looking like this. It is produced like this within the printer with all of the shapes in place already. It is produced with PA12, and the reason why it was produced with PA12 was to increase the grip strength of this pneumatic gripper. And one of the requirements that Continental had for this gripper was that it needed to withstand 1 million cycles. In front of me here, I have an application coming from the German company called Oechsler. Oechsler have used multi-jet fusion to create this seat, and they have used our material TPU for this application. TPU is an elastomer, and it is very soft, and they have used this lattice structure to increase the comfort of the end user and also individually customize these seats for the end user to enhance the comfort. At HP, we also strive towards achieving different certifications, and Class A is one that we have been working on for a while. And Class A certification is a certification that you would need to have on applications that is supposed to be visible in the car. And what we have been able to achieve is, for example, a texture that resembles leather. So this texture is printed directly onto the part. It's not something that is put on top. It's printed directly within the printer. And to showcase other textures that we are able to achieve, for example, here, we have another type of texture that has been printed with HP. And here you can also see a different leather-like texture that is also printed directly. And why we have done this is to help to make the color pop when we have put this color on top afterwards. So behind me right now, we have a lot of healthcare applications. And we see that healthcare is a very growing market for 3D printing because of the possibility to reduce lead time and also the possibility to customize the products to your customers' needs. So for example, we have here a socket. And let's say a socket was produced the traditional way. Your patient will come into your clinic, you will scan the patient, and then you will use the traditional way of milling out the socket. The customer comes back, tries it on, it doesn't fit, and you need to go through the whole process again. So from start to finish to the end product, a customer can look at maybe around 2 months before they actually end up with the product. With 3D printing, together with 3D scanning, you simply scan the patient, you get the file in a CAD file system or CAD file software, you transfer the file to the printer, you print it with whatever material that you would like. The customer comes back, tries it on, you have to do small adjustments, no problem. You take the file back into the CAD software, change the small changes, and put it back into the printer. And by the end of the week, you have a final product. So you reduce the lead time of this product from months down to weeks. In addition to producing socket, producing small orthotics is also very, very beneficial with 3D printing because you can really come down to the smallest details of a customer need, really personalize the product for your customer. And we see this also when it comes to producing insoles, because your feet probably changes from the time that you've been born to the time that you die. So to be able to come into the clinic, scan the patient, and deliver a final product within a couple of days is very beneficial. And that's why we see 3D printing is a growing technology within the healthcare segment.